Hello everyone. In this lecture, I am going to cover some topics of statistics. Those are known as, let me write those topic. First, I want to cover the what does population mean? Population. And number two, sample. Number three, sampling methods. Sampling method. Number four, what is statistic? Number five, what is estimator? Number six, what is parameter? And number seven, what is estimate? So each of these things I will explain in details. And then later I will conduct some computations by using electronic associates incorporations data. Let me write it. Electronic associate incorporation data, and we'll conduct some computations about this. Okay, first of all, what is population? Okay, so population means totality of all elements under study is called populations. Okay, so now I am sharing the screen. I am going to discuss today what is population, what is sample, what are the sampling methods, what is parameter, what is statistics, what is estimator, and what is estimate. And then I will demonstrate some computations by using electronic associate incorporation data. First of all, what is the definition of population? The definition of the population means totality of all elements under study is called the populations. So if electronics associate incorporations has 2500 managers, then all managers will be considered as a populations, because we want to conduct some research on these 2500 managers. Okay, so let me again tell you, what does population mean? Population means totality of all elements under study is called populations. If I want to study a specific disease to deer population in Mississippi, then all deers in Mississippi that are found are considered as a population. If we want to conduct a study of the food habit of the bald eagle in Mississippi, then all bald eagles that are found in Mississippi will be considered as a populations. After populations, then I want to discuss about sample. What does sample mean? Sample means a representative part of the population is called the sample. Remember, sample must be representative. If someone says that a part of the population is sample, or a segment of the population is a sample, a subset of the population is a sample, then it will be wrong. The sample must be representative of the population units. So what is the definition of sample? A representative part. A representative part. Representative. The word representative must be in there. A representative part of the population is called the sample. Okay, so now there are 2500 managers in EAI data. EAI, Electronic Associate Incorporations there is the 2500 managers. In from these 2500 manager, if I take a sample of size randomly, then it will be a representative sample. What do you mean by randomly? Randomly means each unit of the population of size 2500 has an equal chance of being included in the sample. Randomly 30 persons. If I pick randomly, how can I pick randomly 30 of them? Because there are 2500 manager, I can create sleeps. I can create sleeps of 2500, sleep 1, sleep 2, sleep 3, and then up until sleep 2500. 1, 2, 3, and then 2500. Okay. And these 2500 sleeps, I put the name of the 25 managers, and then I mix them in a big box. I put, or jar I mix them, and I randomly put one after another up until I get a sample of size 30. Okay, then that sample will be called the representative sample. Now by using Excel, how can I take a sample? I can take a sample of size 30 like this way. See, take a look. I put here RAN, rand, and then I put like this way. Then a random number between 0 and 1 is generated. So this is the random number. And then if I drag this line up until here, I got 30 numbers. Okay. In this 30 number, if I multiply them by 2500, because there are 2500 persons. So if I multiply by this, then it has been transferred like this way. Now take a look at that. So 2052 numbers that are written in the syllabus sleeps will be included in the sample. 2117 number that was written in the sleep, that person will be included. In that way, the number 52 that are written in the sleep, that would be included. Now there is a decimal number, you can round it up. Okay, you can round it up like this way, round, round it up, and then plug like this way. You can round it up to, you can round it up to, so now see 560, you can say that 1558, 1348, some the manager number 94 or 95 will be included. So this is the way you can take a sample of the desired size by using Excel. So you understand these things, how to take the sample. So remember, a representative part of the population is called the sample, and how to take the sample I have shown you by using Excel. Now there are 4 different types of sampling method which I am going to discuss now. First one is simple random sampling. First one is simple random sampling. So now we are learning sampling method, how to take the samples. Okay, sampling methods. Okay, simple random sampling is will be done when all units of the population are homogeneous. In such a case, all the homogeneous, all the units you should put in a box, and then you draw sample one after another up until you get your desired size. That is the simple random sampling. Each unit of the population has equal probability, equal chance. Everyone has the equal chance of being included in the sample. That sample is known as the simple random sampling. I already discussed what is simple random sampling. Now stratified sampling. Stratified sampling. Stratified sampling you can take when the units are heterogeneous. Heterogeneous. When units are heterogeneous, then you can take stratified sampling. For example, there are first year student, there is a second year student, there are third year students, there are fourth year students, there are master's students, there are PhD students. Let me put, there are fourth year students, there are graduate students. So suppose this has altogether this has 30% students, okay, and this has 20% students, this has 20% students, and this has 20% students, and that has 10% students. Okay, so this is heterogeneous. If I want to take a sample, so altogether suppose 10,000 students, 10,000 students. From these students, I want to take a sample of size 500. The 500 sample would be representative of this proportion, so that 30% of those 500 is coming from first year, approximately 30%, approximately 20% coming from the second year student, approximately 20% coming from the third year student, similarly like that way. If this way, if you take the sample, then that sampling method is known as the stratified sampling. Stratified sampling means heterogeneous population unit, you have to uh, stratify them in homogeneous stratum, and then from each stratum you have to take a sample of your desired size. That's why if you collect the sample, that sample is known as the stratified sampling. Now there is a cluster sampling. Cluster sampling means what? Cluster sampling means, suppose university has a dorm. So this is the dorm 1, D1. This is the dorm 2, dorm 2. This is the dorm 3, dorm 3. In that way, this is the dorm 10. Suppose dorm means the residential hall where student stay. Okay, in this residential hall, all 5 types of students, first year, second year, third year, fourth year, as well as graduate students, they stay in all of these dorm. Okay, so within the dorm, the units are heterogeneous, but between the dorm, units are homogeneous. How? These and that are homogeneous because it has all 5 types of students. It also has the 5 types of students. So between dorms, they are homogeneous. Within dorm, there is a heterogeneity. In such a cases, collecting data from dorm to dorm will be time consuming and expensive. In such a cases, going dorm to collect data is not economically as well as physically feasible. Okay, so in such a cases, instead of going dorm to collect data, randomly pick one dorm, randomly pick one dorm, and then consider each unit of that dorm as your sampling unit. In that way, if you collect sample, that sample is known as the cluster sampling. Now, fourth one is known as the systematic sampling. How to collect systematic sampling? Systematic sampling is easily found in industrial production process. Suppose a industry produced peanut butter. A quality control manager went to the industry at 8 a.m. and he began the process at 9 a.m. and first unit he picked randomly. First unit he picked randomly. First unit he picked randomly. First unit of peanut butter bottle he picked randomly, and then rest of the unit he picked every 999th of the bottle will be picked and sampled, or every 100 bottle, or every 350 bottle. Rest of the procedure will follow a specific pattern. Then the data or the peanut butter bottle that are collected will be considered as a sample unit collected by systematic sampling. Systematic sampling can be collected by time. First unit is taken at 9:21 a.m. and rest of the sampling unit are coming every 1 hour. then at the end of the day, all the units that are connected is known as the sample unit connected by the systematic sampling. Systematic sampling is usually applied in production process. Okay, after that, I want to discuss what is parameter. Okay, what is parameter? Parameter, an unknown constant of population. An unknown constant of population is known as the parameter. Unknown constant, an unknown constant of population is known as parameter. An unknown constant of population is known as parameter. Unknown constant. So for example, EAI data has a 2500 manager, right? 2500 manager. What is their average salary? 2500 average salary. That is unknown, which could be estimated by the sample. So this mu is the mean salary of the 25 manager is a parameter. What is the standard deviation or variance of this 25 manager salary is a unknown constant, which we do not know, which need to be estimated by using sample. So mu and sigma, population mean, population standard deviation is known as the parameter. So, and then proportion, what percentage of the manager completed a training. Training, that means manager needs the training. There are 2500 manager, 1500 of them completed the table training. So 1500 over 2500 is equal to 60%. So that means 60%, which is known as the proportion. So this is the parameter. So population proportion, population standard deviation, population mean, those are unknown constant which consider all population, which you could not get most of the time, like 99% of the time we do not know the populations, but we take a sample and estimate them. That sample collection procedure is applied, and then we estimate this X bar. This is known as the estimate. This S is known as the estimate. This small p is known as the estimate. Estimate represent the approximate value of the populations which is done by collecting the sample. Okay, so you understand what is estimate. Estimate means points is estimate. Now, what is statistic? Statistic. Okay, statistics means function of sample observations. Function of sample observation. Sample observations. Okay, function of sample observation is called the statistics. For example, this, if I put like this, mi and minimum of x1, x2 up until xn. If we consider that one, this is a function of the sample observations. Okay, maximum. And then if I want to find like this, 1 over n sum of x bar, if this is what known as the mean, this is called the statistics. Okay, and now what is statistics means function of sample observations. But what is estimator? What is estimator? Estimator means function of sample observation by using which we estimate the population parameter. That is what known as the estimator. That is what known as the estimator. Function of sample observations by using which we estimate the population parameter is known as the estimator. Function of sample observations by using which we estimate the population parameter is known as the estimator. Now, suppose I want to take a sample of 30. I want to take a sample of 30 manager. Okay, and then sample of 30 manager I have. If I find the average salary of those 30 managers, I goes 30 then this is called the sample mean of sample average or average of the manager's salary. If we compute standard deviations like this by using this formula for those 30 manager, then this is known as the standard deviations of the salary of the 30 manager. Now, if I compute the proportion, if I compute the proportion, I take a sample of 30 manager. Among those 30 manager, if I find that 20 of them completed the training, then this is called the proportion of manager who completed the training. Proportion of manager who completed the training. So that means 0.666, so which is equal to 0.67. So this is the little higher estimate because the way sample came may not be like representative, something like that. So, but this number I just plug. So far from this lecture, what we have learned what is population, what is sample, what are the 4 sampling methods, what is parameter, what is statistics, what is estimator, and what is estimate. And then by using a data, sample data, I have also shown you how to compute some of those things. So if this is the PowerPoint slide, in this PowerPoint size, this is the data. In this data, see, annual salary is in there. If we find the average of this, then we will get the mean salary of the managers. And then are you seeing yes, no? Yes means those people who completed the training. So that means 1, 2, 3, 4. 1, 2, 3, 4, 5. So that means only 5 people did not complete the training. 1, 2, 3, 4, 5. So that means 25 out of 30 completed the training. So that will be the proportion. Sorry, here is also 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6. 11 persons did not complete the training. So 11 out of 30 did not complete the training. 19 out of 30 completed the training. So it is a little bit higher than 60% of like maybe 62 or 63% completed the training. So far, we have learned how to take the sample by using Excel. And one final thing before finishing these slides, you must say always a sample of size 30 is taken from the population. A sample of size n is taken from the populations. Do not get like, do not tell n sample. I have taken n sample. I have taken 30 sample. That is not a correct wording. That is not a good wording. That is a worst wording. But good wording is a sample of size 30. Thank you very much. I'm going to stop in here.